In this recording, we're going to learn how to solve quadratic equations by factoring. Let me put that into perspective a little bit. What basically that means is we're going to find the x-intercepts of the graph without having a graph or table. So let's see what that might look like. So I'm going to fast forward a little bit to the next page and look at the answers. So we're actually going to know what the answers are before beginning the question. You can pick out where the x-intercepts are right here. Now these circles are a little bit off. They should be like right there. So maybe you could change those on your paper on page 17. But we can see where the x-intercepts are. They're at x equals 6 and x equals -7. We can also see in the graph, in the table, that the x values that produce y values of 0 are 6 and -7. Okay, so the table and the graph are saying the same thing. And what we want to do is see how could we find this information algebraically and confirm it by graph. So you might say, well, why would we want to do that? Why would we even do that if we can just get the graph? Well, sometimes the answers are not whole numbers and are not integers. So if we have a technique we can use, it will allow us to solve any quadratic equation, even those that aren't easily found by table or graph. So let's see what we've got here. Basically, what we're trying to find are the x values that make the equation y equal to 0. All right, so let's see what this might look like. Back to the other page. So some words that are synonyms here. A lot of times in math, we're asking the same thing different ways. So if we say to solve a quadratic equation, you might say words like find the solution. So maybe you could underline these with me. Find the roots, okay? Find the zeros, okay? 0 because the y is equal to 0. Find the x-intercepts. Those are all saying basically the same thing. Now, this zero product property, we looked at this before, but we said if we have two numbers we're multiplying and their product is 0, then either one or the other or both of them must be 0. Because when you're multiplying and you get 0, one of the factors must be 0, right? So let's see how that plays out with this particular quadratic. We have this product that equals 0. That must mean that the x plus 3 equals 0, or the x plus 2 equals 0, or that they both equal 0, right? So let's find those values. So what we're going to do is set them equal to 0. And then just solve those out. So take a second to solve those and play the recording. Good, so hopefully you subtracted 3, and you got x equals -3, and you subtracted 2, a little or in there. So we have these two roots, or zeros, or solutions, or also x-intercepts. We found those things. And the way we can write it, when we write the roots, or the zeros, is like this. We write it in set notation because there's a set of x values that are going to produce a y value of 0. All right, so let's solve this question that we already know the answer to. The answers are at the bottom. How could we solve this by factoring? So it turns out that this is a factorable quadratic. So sort of on the right side, it's saying to me what I need to do in general, and over on the left side, what we're going to do specifically for this quadratic. So factor it. Set it equal to 0. So because it's equal to 0, I can find its factors and set them equal to 0. So let's set it up. Set up and solve this quadratic. If you remember, we're going to multiply the 1, that is the coefficient of x squared, now there's the a, times the c, the -42, that's -42. We're looking for factors of -42. So what are some numbers that occur to you? And we want their sum to equal 1. So we might try like 7 and -6. Yep, that works, right? Two numbers that multiply to be -42 and add up to 1. So we're going to go -6x, 7x. The -42 is the bottom right. The x squared is the top left. These on the diagonal add up to 1x. That's good. So we have an x and an x. That's the two products of x squared. The GCF in this column is 7. The GCF in this row is negative 6. So I have my factorization, x plus 7 times x minus 6. And this is equal to 0. I basically just broke apart this quadratic into its factors. Now that's very similar to what we had over here, where we had the two factors equal to 0, and we knew what to do from there. One or both of them must equal 0. So our next step in the process is we set them each equal to 0, and we solve. Now these are going to be easy solves, right? You can already see what the answers are. This one, if we subtract 7 from both sides, is equal to negative 7. And this one, when we add 6, is equal to 6. So we've got our two roots, or our zeros, or our solutions, or our x-intercepts, right? So you now write our solution set. And our final step is to check. I'd like to change some language over here in step 4. I'd like to change plugging in and change that to substituting. That's the correct word. So we're going to check by substituting these roots separately into the original equation. So something like this. Now when you're substituting a negative, especially when there's squaring involved, parentheses are the key. So I'm substituting in negative 7 into that original equation, and I want to see if it equals 0. 49 minus 7 is 42. 42 minus 42 is 0. Yep, that equals 0. Now the other, I'm going to substitute in a 6, so no harm in putting parentheses around the 6 either. Okay, so let's check this one out. We've got 36 plus 36, that's 42. 42 minus 42, yep, that's 0. You can use a calculator, but we also can figure it out in our head. All right, we can also confirm these answers by our table. So there's our negative 7, and there's our 6, and then on the x-axis, these are our x-intercepts at 6 and at negative 7. So I think you have a pretty good handle on the process here. I'd like you to try one on your own. So on the next page, I'd like you to factor, and then I would like you to solve for, we're going to make this basically a 0. So the first thing you're going to do is make it 0 equals, because we're finding the points on the graph where the y value is 0, in other words, the x-intercepts. After you've factored and solved, I'd like you to make the table and make the graph and confirm your roots. So do this all on your own. Play the recording when you want to see the answers. Okay, so hopefully you took the time. If you didn't take the time yet, don't play the video any further until you've gotten as far as you possibly can on your own. Okay, so we need to do the factorization here. So we're finding the values where the y is equal to 0. So we'll do our factoring over here. Factors of 12, 1 and 12, 2 and 6. I don't need to think about any negatives, right? Because we don't see any negatives. 3 and 4. Yep, that's the one. 3 and 4. So now we have our factorization. Let's set each one of those factors equal to 0, because our zero product property says one or both of them must be 0. So now we have our roots at negative 4 and negative 3. I'll write the solution set. We can check by substituting. We're also going to check by graph. So if you had a graphing calculator, you could put this into the graphing calculator. You could also use Desmos. There's our table. You can see it kind of has a flat tire here right in the middle, right? We've got symmetry, but there's obviously a point that's missing in between here at the negative 3.5. So one thing we can do is we can find that vertex. So All right, so we know the vertex, the axis of symmetry must pass through it. So we've got our x equals opposite of b over 2a. So in other words, x equals opposite of 7 over 2. So that's negative 3.5. That makes sense because we saw that there was repetition up to the point of negative 4, and then the repetition started over at negative 3. So obviously in here at negative 3.5, there needed to be another point where it got to the lowest point, the minimum y value. To find that y value, we need to do a substitution. I'm substituting in that negative 3.5 in for x. And when I do this math, I get the y is equal to negative 0.25. So the vertex, the lowest point, or the turning point, is at negative 3.5, comma, negative 0.25. All right, and that's consistent here. You see that we get down, 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 and just a little bit down. So plot all those points, and then play the recording when you're ready. All right, now for the moment of truth. Does everything check? Well, we have x-intercepts at negative 4 and negative 3. We have the solutions at negative 3 and negative 4. And then we have the zeros shown by the table at negative 4 and negative 3. It all matches. Thanks for watching.